All right, today we're going to be getting into Unit 2, which is dealing with matrices. And today's lesson is all just the very basics and some vocabulary. So figured you could handle this one in a video. A matrix is an array of numbers. It's just a bunch of numbers in a box. When we talk about matrices, we talk about them and their rows and columns. You need to know how to pick out a row, how to pick out a column. Rows go left and right, columns go up and down. When asked about the dimensions of a matrix, it's always the number of rows and then a little x, number of columns. So you would say a 2x4, like a 2x4 piece of board, okay, 2 rows, 4 columns, but you say 2x4. So matrix A, if we're determining the dimensions of matrix A, okay, rows go left and right, so it's got 2 rows and 3 columns. So matrix A is a 2x3. Within each matrix, we refer to each individual number as an element. And these elements have names. We have to refer to them as something. So if I have a big, huge matrix, people use matrices for data, stuff like that, data analysis. If there's a bunch of numbers in it, I need to be able to pinpoint exactly like which one I'm talking about. So usually we'll give a lowercase letter. So like if I'm talking about matrix A, I'm going to use a lowercase a. And then it's got 2 little numbers down at the bottom. When it's written at the bottom like that, we call that a subscript. And so we'll just do this example. This is not B12. It's really, I read it as B12. So the first number is your row number. The second one is your column number. So if I'm looking for B12, I'm going to look at matrix B. I want to know what number is in row 1, column 2. So row 1, rows go left and right. So this is row 1, row 2. This is column 1, column 2. So row 1, column 2 is -8. Sometimes people like to circle row 1 and circle column 2 to see where they overlap. All right, so some examples here. Number 1, matrix B. Well, we've already decided there's 2 rows, 2 columns. So it's a 2x2. And then I'm going to do 4 and 5 and let you work on these by yourself. So A21 means I'm going to look at matrix A, row 2. So I'm looking in the bottom row, column 1. So row 2, column 1, if you want to circle, row 2, column 1, where I overlapped is a 7. And B, B, 2, 2. So I'm looking at row 2, column 2. There's going to be a 6 there. Pause the video and work out the rest of the questions on this page. Okay, F, you should have got 2 by 2. It's a pretty easy one. C is one of the ones that will always mess people up. So if you look at C, if I think about it, rows go left and right. So if I'm going to take my highlighter and go left to right, I can get one row. Columns go up and down. So if I do columns, 1, 2, 3 columns. So it's a 1 by 3. A lot of people get those numbers flipped, or they say 0, like 1 by 0 or something. So 1 row, 3 columns. All right, number 6 said to find C11. So row 1, column 1, there is a -2. D13, so we're looking at D, row 1, column 3 is 11. E31, so E has 3 rows, but only 1 column. So E31 would be the bottom row, the only column is -9. And F21 would be row 2, column 1, that's a 0. And then we're going to just quickly talk about square matrices. You may have some questions where you have to identify the type of matrix that it is. So a square matrix has the same number of rows and columns. So it could be a 1 by 1. It could be a 2 by 2. It could be a 3 by 3. And so on. Doesn't matter what numbers are in there, but there's 3 rows, 3 columns. A zero matrix is the matrix in which all elements are 0. Does not matter the size of it. That's a 2 by 4 matrix. All elements are 0. A row matrix has exactly 1 row. And rows go this way, so it's just a long matrix. I'm just making up numbers. That's a row matrix. This is a 1 by 6. A column matrix has exactly 1 column. You know, columns go up and down. This is a 5 by 1 matrix. And the last one is a square matrix, or not a square, an identity matrix. It has to be a square matrix that has 1s on the diagonal from the top left to the bottom right. So, like in this diagonal, all of the elements this way are ones and zeros everywhere else. So for example, a 2 by 2, those would be ones and those would be zeros. The ones go in this diagonal. A 3 by 3 would have ones there and zeros everywhere else. They have to be positive ones. They have to be going in this diagonal, not over here. See if you can make a 4 by 4. And this is what it should look like. And that is all for the first lesson.